Hi, my name is Amanda Rigdon, and I'd like to talk to you for about 25 minutes today about sample preparation of cannabinoids in urine using the QueChERS method and DSPE cleanup. So to begin, what is QueChERS? Those of you who have done any sort of food or environmental analyses may know that QueChERS is becoming more widely accepted for extraction of various pesticides from matrices such as fruits and vegetables. QueChERS is essentially the addition of acetonitrile and buffering salts to a matrix with centrifugation in order to clean up the sample. So what we're doing here, instead of taking out our pesticide analytes, what we're doing is we're removing any sort of matrix components that may interfere with our analysis. And there is a second part to QueChERS that can be used and sometimes is not used. That second part is dispersive solid phase extraction cleanup. What this is a second cleanup step to clean up more matrix components from our pesticide residues or our analytes of interest. And what does QueChERS stand for? It stands for quick, easy, cheap, effective, rugged, and safe. So some other applications for QueChERS include antibiotics in honey, pesticides, acrylamides, and veterinary drugs in meat. And last but not least, pharmaceuticals in whole blood. In a paper published in the Journal of Chromatography A in 2006, Florian Plosel and others showed the extraction of several drugs in blood using the QueChERS approach. One thing to note from the table in the paper here is the excellent recoveries for the most part of the varying analytes in the blood. This gave us hope that perhaps we would be able to apply the same QueChERS extraction to drugs of abuse in urine, since these are pretty much the same kind of thing in a biological matrix. So some possible benefits for QueChERS over SPE cartridges for drugs of abuse are, first and foremost, lower material costs. All QueChERS is, basically, is some salts added to our sample with a little bit of acetonitrile on the order of a couple of mils. So that means the only thing that we need to do this extraction are our salts, some acetonitrile, and some centrifuge tubes, as well as a centrifuge. We don't need an SPE manifold, we don't need to buy SPE tubes, we don't need any of that. So this does greatly reduce our material costs. Additionally, there is much less sample handling, which leads to faster batch extractions. The total extraction time for one sample, or for a batch of samples, is about 20 to 30 minutes, which is not bad at all. That's including drying down and derivatizing. And also, for some drugs, we can get higher analyte recoveries using QueChERS as opposed to SPE cartridges. The main benefit for using QueChERS over SPE cartridges could be its use for multi-drug class capabilities. Since we're only cleaning up a matrix instead of trying to extract out our analytes of interest, we will be able to use QueChERS to analyze for several different drug classes at once, such as a panel including amphetamines, barbiturates, benzos, cannabinoids, etc. So let's move on to the work that we did. We focused mainly on cannabinoids in urine. The two cannabinoids that we focused on are delta-9 THC, which is the chief psychoactive component in cannabis, as well as carboxy THC, which is the main metabolite tested for in urine cannabis analysis. The cutoff for carboxy THC is 15 nanograms per mil, and we applied that cutoff to our other analytes as well. So this is just an overview of our GCMS conditions. We used a 15-meter column, an RXI 5 SIL-MS with a 5-meter IntegraGuard. The reason why we went with the shorter column is because we wanted to reduce our analysis time as much as possible. We also used a single quad mass spec, Shimadzu QP 2010 Plus, and we collected data, full scan data from 50 to 550 M/Z, as well as doing selected ion monitoring experiments for quantitation. So this is a table of our quant and qual ions for each of our analytes. As you can see, we did analyze for other cannabinoids other than carboxy THC and THC, but what we're going to focus on today is carboxy-THC and THC. So this is our modified QueChERS method for cannabinoids in urine. One thing that we did have to add here that was not talked about earlier for pesticides is that we need to do some sort of alkaline hydrolysis or removal of the glucuronide from the carboxy-THC glucuronide. So in order to do this, we did an alkaline hydrolysis reaction, which is simply 4.5 mils of urine with 0.5 mils of 10-normal potassium hydroxide heated to 60 degrees for 20 minutes. This will remove the glucuronide from the carboxy-THC as well as removing the glucuronide from any other glucuronidated species in the urine. After this time, we neutralized our sample or brought the pH of our sample back down to less than 2.5 by adding approximately 50 microliters of 12-normal hydrochloric acid. After alkaline hydrolysis, we moved on to our QueChERS extraction. For our QueChERS extraction, we used 5 mils of acetonitrile per 4.5 mils of sample. One thing to note here is that these amounts can be changed depending on our sample amount. So if we wanted to have our usage of acetonitrile, we would just divide our urine sample in half, as well as dividing our salts in half. The reason why we did that is because the reason why we used 5 mils is because we wanted to have a good amount of extract to work with later on. But that is just one thing to note. So we did use 5 mils of acetonitrile, shook it for 1 minute, then added quickly 2 grams of magnesium sulfate and 0.5 grams of sodium chloride. We shook that for 1 minute. One thing to note here is that upon addition of the salts, the sample will get hot, so venting may be necessary. After shaking, we centrifuged for 10 minutes and removed our extract. And that's basically the QueChERS extraction. It is very easy, and this is a very, very good first cleanup step. And in many cases, this is the only cleanup step that we'll need. So after we removed our extract, we had to move forward with derivatization. So we evaporated 1 mil of our QueChERS extract to dryness at about 30 degrees and added 50 microliters of our derivatization reagent, which was BSTFA plus 1% TMCS. We incubated that at 70 degrees for 25 minutes. And after that, we did do a dilution step of 1 to 5 with ethyl acetate. This dilution step isn't necessary, but we wanted to have more sample to work with. So this is just a photo essay of the process of our QueChERS extraction. This is just simply our urine sample, which will undergo alkaline hydrolysis. After alkaline hydrolysis, our 5 mils of acetonitrile are added and the sample is shaken. You can see here that there are not 2 separate phases of acetonitrile in urine, obviously because acetonitrile and urine are miscible. However, once we add our salts, as you can see on the left, and shake, after centrifugation, we can see that we've formed 3 phases. Our bottom phase is our salt pellet. We have our middle phase, which is most of our urine components, and our upper layer is approximately 5 mils of acetonitrile. This is our final extract that we'll work with. This is a picture of our sample. On the left, our dried down sample, and on the right, this is the sample after derivatization. As you can see, it is pretty dirty. So what we could have done before drying it down, we could have done some additional cleanup using dispersive solid phase extraction. So let's talk about that a little bit. What is dispersive solid phase extraction exactly? All it is shaking loose SPE sorbent with the sample extract to clean up our sample. So instead of passing our sample through an SPE tube and doing our rinses and drying steps and our elution steps, all we do is we shake our sorbent with our sample. The aim of this is to remove any matrix components from our sample, not to remove our analytes from the sample. So there are a few different DSPE sorbents that we can use. We can use primary and secondary amine, commonly known as PSA. This is very, very good for removing sugars, fatty acids, and anything that will hydrogen bond. C18, which is an octadecyl phase. This removes lipids and hydrophobic compounds. and graphitized carbon black. GCB is very, very good for removing pigments and planar compounds. So it's widely used in cleanup of like spinach extracts. So just to give you an idea of the amount of analyte that's actually present in our sample and why we need to do DSPE, if we look at our cutoff level of 15 nanograms per mil, our extract will have 54 picograms per microliter of our carboxy THC or THC in it. And if we're doing a 1 microliter injection, that means we're going to have 54 picograms on column, which isn't bad if we're looking at a standard. However, if we consider the levels of matrix components that are still present after our extraction, this is not very much, and our analyte may get lost in our matrix background. So this is why DSPE can be very important for cleaning up our samples further. So let's look at some of the effects that we got from our DSPE extraction cleanup. So what we're seeing here is our region of elution for our cannabinoids. On the left, we can see a urine extract that was subjected to the QueChERS extraction with just the salts, but no dispersive solid phase extraction after the QueChERS extraction. And on the right, we can see the QueChERS extract further cleaned up with our DSPE PSA. The main thing to note here is the difference between the left and the right. First off, there are less peaks. There are less matrix peaks. Also, one thing to note is that overall, the baseline is much, much lower after PSA cleanup. This means that we've cleaned up a very large amount of our matrix components, which will help us pull out our analyte later on. So based on the chromatograms we saw before, the PSA cleanup looks like it does a very good job, right? However, if we look at our recoveries, we can see that our recovery for our carboxy THC is only 7.64%. So why is this? Well, the reason why is that our PSA is very, very good at removing any sort of hydrogen bonders, meaning carboxy THC. The carboxylic acid is actually being removed by this PSA. So although PSA is very, very good at cleaning up, it also removes our carboxy THC, unfortunately. So since the PSA didn't work, let's see what happens with our graphitized carbon black. If we think back to a previous slide, GCB is very good for removing planar compounds as well as pigments. So our first experiment was just a straight graphitized carbon black dispersive SPE of our QueChERS extract. And you can see here that our recoveries for both cannabinol and carboxy THC were very, very low. They were so low as not to be acceptable. However, when we added a planar solvent such as toluene, so instead of just putting our acetonitrile extract into our tube with our graphitized carbon black, we put 3 parts of our extract and added 1 part of toluene, which is a planar solvent. When we did this, our recoveries improved dramatically. The reason for this is because graphitized carbon black is very, very good for removing planar compounds. However, sometimes it's a little bit too good. So with the addition of toluene, it kind of mitigates that cleanup effect. So even though the cleanup effect is somewhat mitigated by the addition of toluene, we can see from the difference in our 2 chromatograms, our chromatogram on the left, our urine extract with no dispersive SPE cleanup, and our chromatogram on the right with our graphitized carbon black cleanup with acetonitrile with the addition of toluene, we can still see a drop in baseline as well as the reduction in the number of peaks from our matrix. This translates to an overall reduction in matrix interference, which is what we're looking for. And as you can see here, we do have, for our carboxy THC, we did a little calibration curve, and it was linear over 2.5 to 100 nanograms per mil in urine. We did calibration curves for our other compounds as well, but I'm not going to bore you with those. Those were also very good. our R-squared values were over 0.99. So just to take a look at our chromatograms for our quant and qual ions for our carboxy THC at our different levels, we can see here at the 100 nanogram per mil level, we have very good response, as well as at the 25 nanogram per mil level. When we move down to 2.5 nanograms per mil, we're getting a little bit lost in the matrix still, even with all of our cleanup. And if we look over here at a zoomed in version of the chromatogram on the left, this is a zoom of our carboxy THC, we can see that our 371, our quant ion, is actually a little bit higher than it should be. The reason for this is because of an isobaric matrix interference. So this did throw off our results a little bit. However, this might be able to be mitigated by further cleanup or better chromatographic separation. So in conclusion, from our experiments, we found that QueChERS with dispersive solid phase extraction does show promise for sample preparation of cannabinoids in urine. However, we need to develop some better DSPE method for cleaner extracts if we want to look at those very, very low levels. Additionally, QueChERS should be evaluated for multi-drug class sample preparation because this is where it'll really shine and it'll really have a lot of value in saving money over traditional SPE cleanup methods. And finally, I'd just like to acknowledge Rick Moorhead at ResTech for his helpful discussions and a review of this presentation. Thank you very much.